Hi everyone, today we're going to take a look at an old Keithley digital multimeter, model 168, which was manufactured way back in the early 1970s. This particular meter had a 4-digit display. It was auto-ranging, one of the very early auto-ranging multimeters for the time, and it has an accuracy on the DC voltage range of 0.1%. The AC range's accuracy is around 0.5%, and on the ohms ranges you have an accuracy of around 0.3%, plus or minus 0.3%. So we'll have a little quick look at the functions on this meter very quickly, and then we'll take it apart and see exactly what's inside. Right, looking at the front of the meter, we have a group of buttons here. The first 4 buttons are all to do with the power. This particular model also came with a rechargeable battery pack which was built into the meter. The one I have here at the moment doesn't have that feature, but if you had the rechargeable battery pack installed, then you have 2 buttons here which are used for battery mode. This button here is used when charging the battery, and this button here is used to switch the meter on using the internal battery. If you're in the off mode, normally the red button is pressed in for off. To power the meter on from the main supply, you simply press the line button and the meter is now on. Because this model doesn't have the battery pack, these next 2 buttons are not used. Right, the other buttons here are the function buttons. I'll cover these group of 4 here first of all. These are the volts and the amps buttons. You have a DC button when it's pressed in for the DC ranges on voltage and current. The AC button again for voltage and current. And then we have 2 buttons here which determine the current range. One is labelled milliamps and one is labelled amps. And the interesting point about these 2 buttons is they've got a lockout function. So if I were to press the milliamp button in on the DC range, if I try to press in the amp button at the same time, it doesn't allow you to do it. You have to release the milliamp button first before you can then press in the amps key. The other interesting thing about the functions here is you have a number of LEDs, single LEDs here behind the front panel, which light up and tell you exactly what function you're on. So here we can see the DC LED is lit and the amps LED is lit. If I release the amps and put the milliamps one on, you'll see the milliamps LED is lit. And you have a similar feature as well when you go to the AC range. So pressing the AC, the only thing that's changed there is the AC LED is now lit, and again you have the milliamp button pressed in and the milliamp light lit. Again, release the milliamp button, the amps button in, and you get the amps light on as well. Okay, if I then go back into the DC range, release the current key, we have 2 keys here associated with the ohms readings, a high and low ohms. That just you have 2 ranges basically, and when you press in the ohms button, you find that you get one of the LEDs lit here. There's, at the moment it's on kilo ohms, so you'll see the kilo ohms LED is lit. If the meter then switches to or measures a resistor with mega ohms, it'll switch over to the mega ohms LED just below. In this far right hand corner you have a little opening in the front panel, and behind there you have a preset resistor which can be used to zero the meter. So for example, if you're on the ohms range, you could short your leads together and you could then zero the meter using the little trimmer behind that slot there on the front panel. Okay, a quick look at the back of the meter. Okay, on the back of the meter here, the only thing we have here is the switches for the mains voltage range, and they're all clearly marked on this diagram here. There's a table there showing exactly which way the switches need to be for which particular supply voltage you have. On the underside of the meter you have a sticker there with all the details of the meter. Really, it gives you details about all the ranges and the accuracy, and information here about the line voltage setting and the battery pack. One other point, as far as the mains lead is concerned, under the feet there's actually a recess which can be used when you're stacking away the mains cable. Okay, well, let's take it apart and let's have a look at what's inside. To take the meter apart, we need to remove the case, and we do that by removing the fixing screws on the bottom of the meter there. There's 4 screws. These screws feel as though they won't come out, so there must be some retaining system on the screws, so I'll just slacken them off. And turn the meter back round again. And the top cover should come away. That's interesting. Under the cover we have all the calibration information. We'll come back to that later. Okay, so there we have the meter. It seems to be all on one printed circuit board, apart from the front panel here with the display, which is another small printed circuit board, which I'll remove in a moment. So first of all, what I will do, I'll remove the tilting bail, and then we'll remove there's some spacers there, remove those. Okay, alright, because we can see now why the screws didn't come away. There's a little rubber washer on those screws which are retaining those screws. So even though we've managed to remove the top cover, the screws remain. That's a good idea, remain in the casing. Okay, so we should be able to lift this whole assembly out of the no, wait a minute. Oh, we have to remove the mains connector there. So remove the mains connector, and we should now be able to lift the whole panel out. There we are. I can remove the bottom panel now. On the bottom again we have some screening here. This is quite common with a lot of the Keithley meters. We have some screening which is then screened by having a little spring clip that goes onto this metal. Right, I think what I'll do next, I'll remove this the front display unit here, and we have there's a power connector there. Remove that, and we have a ribbon cable which we need to remove. And then we can ease the panel away, and then we just need to remove the clips on the input terminals there. Right, okay, and that's the front panel assembly away. Not a great deal on there, apart from a small printed circuit board with the 7-segment displays and the indicating LEDs for the different ranges. We may have a little look at that in more detail later. I'll just put it to the side for now. Okay, so the next thing I'll need to do is remove this this screening can here, and it appears to be clipped in, although there is one screw. There's one screw there, and that also is retaining a spring clip, which is the clip that's used to earth the screening on the bottom of the case. So if we remove the screw, the clip comes away, and now we should be able to unclip that that whole module. There's some retaining spring clips there, and another one just there. There we are. So that's the screening cover removed from really the sensitive part of the meter, the front end of the meter there. Okay, I'll just zoom in a little bit more. Right, just a very quick overview of the meter. Just looking at it at the moment, we can see in this corner here we have the main power supply, and I'll zoom into that in a moment and we'll have a closer look at that. This area here is obviously the input circuitry to the meter. You have all the calibration presets along here. You have a current shunt resistor here, a large one, 1 ohm resistor, 0.1%. I would imagine these two fuses here are on the current ranges. And then in this area here, which is obviously the logic, the digital part of the board, we'll zoom into that and have a closer look, but I can see they're using a large IC there, which is obviously the heart of the meter. I'll have a look at that in a moment and we'll try and identify that. At the back of the meter here we have the mains input fuses. They're using 2 fuses, and the 2 slider switches here are to select the voltage, the mains voltage setting on the mains transformer. In this corner here we have a socket which is used if the meter has the rechargeable battery pack. In this case it didn't come with that, but that socket is used for the rechargeable battery pack. Okay, I'll zoom into the different sections of the meter and we'll have a closer look and see what we can find. Right, here we can see the closer look there of the power supply section. Mains transformer, it's actually got 2 windings on the primary, and they're just switching them depending on whether you're on the 240 volt ranges or you're on the 110, 115 volt ranges. You have 2 bridge rectifiers there, and on this side you have a voltage regulator, which is a 5 volt regulator IC on a heatsink. That's giving obviously the main plus 5 volt supply to all the chips on the board. And on the other side here we have another voltage regulator IC, which is a 12 volt regulator, and its associated capacitor is here. The way they have this wired up at the moment is that they're generating a negative 12 volt supply, whereas the 5 volt supply here is a positive 5 volt supply. So it's quite simple. That's the power supply part of the board there. Okay, let's zoom in and have a look then around the input circuitry here. Right, here we have the input circuitry of the meter. In this corner here we have a operational amplifier, which is the input amplifier. It's a National Semiconductor IC LH0022, and the gain of that amplifier is determined by a resistor network in its feedback arrangement. and that's achieved by switching in. There's a resistor network here which is a Caddock high tolerance resistor network, and you have some FET transistors here, and they will switch in different resistor values for the operational amplifier, adjusting the gain of the meter depending on what range you've selected. Here we have some strange components. These three things here are actually trimming capacitors. In the ends of them here you can put a trimming tool and adjust the capacitance of those three. They must be compensating for the input frequency tolerances of the meter. Over here we have another IC. You can just see it on the edge there, and that is used in conjunction with the input IC there to give additional gain on some of the other ranges of the meter. Okay, I'll just move the camera over and we'll have a look at the corner of the meter and the inputs area there. There you can clearly see the large resistor there, the 1 ohm resistor, 0.1%, which is one of the current shunt resistors. There's the two fuses in the current ranges, and over here you can see there's a green, what appears to be a green IC there. That is in fact a resistor network, and in fact when we zoom out again and look at the whole of the board, you'll see they use quite a lot of these resistor networks in a DIL package. And in this bottom corner here you've got the this one here, bottom corner, the blue. You have the adjustment, the zero adjustment, which I mentioned, which is accessible from the front of the meter. Okay, let's move the camera and look at the other side of the board. Okay, in this area of the board here, some more logic ICs. They're all linked to the main processor IC we mentioned earlier, that's carrying out all the functions basically for this meter. But the one of interest is this one here, which is a TTL logic IC. In fact, it's just inverters, and they're using them to generate a clock signal together with these two capacitors here of around about 9 or 10 kilohertz, which is then used for the main chip, which I mentioned earlier on, which is controlling all the functions of the meter. Again, here you can see the mains fuses right in the back there. Right, this seems to be the heart of the meter here, this particular IC, which is a 74360N. This particular IC does most of the logic functions for the meter. In fact, what you have in there is amplifiers, you have analog to digital converter, you have the drivers and the multiplexing for the display. So this particular chip was actually designed at the time for digital multimeters, and Keithley have really just used that and interfaced that into their design together with a few other TTL logic ICs. In this corner here you can see we actually have a group of 4 transistors in a black casing there, and those transistors are used to drive the anodes of the 7-segment LED displays. Again, you can see we have some resistor networks here, the green, pale green colour there. And there is the connector for the main display. Right, so there again we have all of this section of the meter here is the digital logic circuitry of the meter, all around this particular chip here. The other interesting point to note here, this particular IC that was manufactured at that time was designed for meters, digital meters with only 4 ranges. This particular Keithley meter has 5 ranges, and therefore they had to put some additional logic ICs in to give them that extra range and move the decimal point on the display. We'll just have a quick look at the front display there. It seems to be held on with just some rubber washers here over some plastic spigots, so if we just ease them off. Right, and then hopefully the whole display should just come away. Okay, so there we have the front of the display module there. The 7-segment displays, the single LEDs over here, which are simply used to indicate what range you're on, and that's really about it. The power leads are coming out of the side, and the controlling leads for the display itself are on from the ribbon cable at the other side. So quite a simple module, nothing sophisticated about that. The back of the front panel, the input sockets there is simply just bolted onto the front panel there with the spade connectors. Okay. If you happen to buy one of these meters off sites like eBay, one of the common faults you'll find is that these two input fuses here tend to blow. The ones that I found on eBay, you find that the DC voltage range works fine, but the current range and the ohms ranges don't work, and it's down to these two fuses. The ohms range doesn't work either, and the reason behind that is that it uses a constant current source on the input circuit of the meter, where there's a feed through on the current range as well. So just worth bearing in mind if you get one of these and you say, oops, the ohms range is not working, worth just checking these. Here's a look under the top cover of the meter, where they've stuck a label here which shows the calibration information for the meter. A nice little touch, I think. Well, I hope you found that teardown of this Keithley 168 digital multimeter of interest, and I'll see you all again next time. Bye for now.